Hey, what's going on, guys? In this video we are going to see how to find out the Laplace transform of this initial value problem. Okay, here we have y0 given, that is -1, and y prime of 0 given, that is 6. And here you have to know these three things, like when we have y double prime, what is the Laplace transform of that, and when we have y prime, what is the Laplace transform of that. And also, if you you have to know what is the Laplace transform of y. These are the three things you have to know in order to solve this problem. And if you don't know that, I have made a video on that, so you can see it clearly. Laplace transform of y double prime, when we have second derivative, the Laplace transform will end up like this. We will have s square y of s, and then minus s times, we will have the initial value, that is y of 0. We will have y of 0 after that. Instead of y of 0, I directly put -1. This is our y of 0. Y of 0. And then after that we have to have y prime of 0, that is 6 in our case, minus y prime of 0, that is 6. This is the expansion of y double prime alone, okay, y prime of 0. Now after that we have to take care of this 6y prime, so I put the 6 in front, and y prime is basically s times y of s, minus y of 0, that is -1. I put the -1 right here, and that is y of 0, and this is the expansion of 6y prime. And then we have finally 9y right here. If we expand 9y, that's going to be 9. Laplace transform of y, that's going to be just y of s. The whole thing is equal to 0. Okay, the next thing is we are going to simplify everything. And if you simplify, if you take a look at the terms that's with y of s, this is with y of s, and this things with y of s, and here we have another one with y of s, okay. And if we combine all together, if we take take y of s as common, we will end up with s square in the first one, and then here we have 6s, so 6s right here, and after that we have a 9 right here. All of them are multiplied by y of s. And if you notice, here we have plus 6, and also this one minus 1, that's going to be plus 1, so that's going to turn into this whole thing. If you multiply this one, this is going to be plus 6 right here, and here we have -6 plus 6 cancels, so we can get rid of this one. And here we have a positive s, right, minus s, that's going to be plus s. So if we move that one to other side of the equation, that's going to be -s. This is equal to minus s. Now if we write this one here, we have to take the Laplace transform of y of s. That's our purpose, y of s. And here what we have to do is we have to take the Laplace inverse to find out the final solution, because now we have converted this one into s world. Now we have to take the Laplace inverse to find out the real solution. So minus s over s squared plus 6. I'm moving this whole thing to the other side. 6s plus 9 is right here. Now we are going to take the Laplace inverse of this one. To take the Laplace inverse of this one, we can try to factor this one. Here it's already factorable because this is a complete square. So we can write this one as s. Here we have -s right here. I move the negative, we have to take the Laplace inverse of this whole thing. Laplace inverse, I put the negative in front, and we have Laplace inverse, and here we have, okay, let me erase this one. Laplace inverse of s over, if we take this is a complete square, this is going to turn into s plus 3 whole square. And now to make this one simpler, what we can do is we can add and subtract 3. If we do that, plus 3 minus 3 right here, and here we can do the separation. So this will become, since we have let's put minus Laplace inverse, and here you can see s plus 3, and in the denominator we have s plus 3 square, so s plus 3 and s plus 3 square cancels each other, and we will have 1 on the top. And since we have s plus 3 square, the square will cancel, we will have 1 power because 1 is cancelled already, so we will have s plus 3 in the denominator. and we have minus 3 because we just taken care of all this part. We have minus 3 with the same denominator, so we have to move this one to another one. So let's take this negative common, and I close this one and write the next thing after this. Okay, let's get rid of this bracket because negative is common for both of them. So I put, after that we have minus 3 right here. Minus 3 Laplace inverse of, I took the minus 3, the denominator remains the same, but here we have s plus 3 whole square. S plus 3 whole square, and we have to find the Laplace transform of this. Okay, now let's go ahead and do the Laplace transform. Let's continue right here. So first of all we have minus Laplace inverse of 1 over s plus 3. Okay, 1 over s plus 3. This is like e power. When we have 1 over s plus 3, we can directly put it as e power. This is a minus a, so minus 3t. That's the Laplace transform of this. And minus will distribute here. Minus minus turn into plus, so we will have a plus 3. And after that we have to find out the Laplace inverse of this one, 1 over s plus 3 square. Now to find out this one, you can think it as 1 over, if you have 1 over s power 1 plus 1, that is equivalent to t, right? But if you have a plus 3, that's a shift. So the shift is going to be e power, since s minus a, so e power negative 3 right here, 3t. And this is, since this is a square, we can write it as 1 plus 1. Because we have to have 1 factorial and 1 right here in order to have t power 1. So this is going to be that. So this whole thing is e power negative 3 t power 1. So 3 multiplied by e power negative 3t t. That's the final Laplace transform. And if we write this one in a better way, the Laplace transform y of t is basically equivalent to negative e power negative 3t plus 3t e power negative 3t. And that's how we solve an initial problem like this using Laplace transform. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.